Good evening and welcome everyone to this lecture. We are dealing with electric dipole and this is lecture number 15. Let us have a quick recap of what we have done upon studied about dipole. Dipole is nothing but an arrangement of two charges separated by a very small distance. One charge is positive, other is negative. The total charge is zero. The distance between the two charges is known as the dipole or the dipole axis, length of the dipole or dipole axis. To characterize every dipole, to find out what any dipole or to find out the strength of any dipole, I have a vector which is known as the dipole moment. The value of dipole moment is q multiplied by the dipole axis, and the direction of the dipole moment, which is a vector quantity, is from the negative charge towards the positive charge. We all remember this? We had seen the electric field and potential due to a dipole at different points. We have seen the electric field and potential due to a dipole at axial points on the axis, and we had also seen the electric field and potential due to dipole at the equatorial points. Do we remember this? Yes or no?
Yes,
You'll have to remember this formula. We are very unlikely to get question on electric dipole, so we will try to wind it up quickly, but since it is a part of your course, you have to do it. The last topic that we were discussing was electric field at any general point due to a dipole, and we had given this formula ER along the direction of R is 2p cos theta by R cube. E theta, which is perpendicular to this, it is kp sin theta by R cube. The net value of electric field will be the sum of this square plus that square. The net electric field, if you can remember this formula, Kp by R cube into 1 plus 3 cos square theta, that would be great. And the value of this angle, tan of phi. I hope you can see this angle phi, yes or no? The value of this tan of phi is given by half of tan theta. Apart from this, you must also know the value of electric potential at any general point. At any general point, this was the electric field at any general point. Potential at any general point can be written in this form: Kp cos theta divided by R square. Kp cos theta divided by R square. This is the way in which you can find out the general field and general potential at any point. I hope you have drawn this diagram, everyone. The only thing that was missing in this diagram was the value of V at any general point, and this is the formula here. If you put the value of theta as 0, you will get the potential on the equatorial point. If you put theta as 90, if you put theta as 0, you will get the value of potential on the axial point. If you put theta as 90 degrees, you will get the value of potential at the equatorial point. Do we understand this? Yes or no?
yes, sir.
Now, this was electric dipole in the chapter which is coming up. Magnetic field is the chapter which is coming up. In that magnetic field, you will come across something which is known as magnetic dipole. Magnetic dipole is nothing but a magnet. A magnet has two poles, south pole and the north pole. Do we know this? Yes or no? So this electric dipole has actually come from the concept of magnetic dipole. A magnetic dipole looks like this. It is nothing but a bar magnet. Do you understand the meaning of a bar magnet, beta? A magnet that looks like a chocolate bar. That is known as a bar magnet. So whatever we have done for electric dipole, the same is true for a bar magnet. So now you can note down both the formulas together. On the left hand side, you have the formula for electric dipole. Electric dipole has a negative charge minus q and a positive charge plus q separated by a distance of 2L. For a bar magnet, the south pole is known as the negative pole. The north pole is known as the positive pole. It also has a dipole moment. Here the dipole moment is known as, for electric dipole, dipole moment is known as electric dipole moment written by the letter P. Here it is known as magnetic dipole moment written by the letter M, M vector. Electric dipole moment is from negative charge to the positive charge. Magnetic dipole moment is from the negative pole, which is the south pole, to the north pole. The value of electric dipole moment is Q into 2L. The value of magnetic dipole moment is M into 2L, where M is known as the pole strength, strength of the north pole, strength of the south pole, strength of the north pole, strength of the south pole. Do we understand this? Yes or no? So whatever we have done for electric dipole, the same thing is true for magnetic dipole. So you can write these formulas together. If you can write these formulas together, you can understand both of these things together because they are exactly same. The only difference is in electric dipole, P will be written as electric dipole moment. In bar magnet, M will be written as magnetic dipole moment. That is the only difference, my dear friends, between the two formulae. Do we understand this? Yes or no?
Yes, sir.
So you can note down this formulae in this form also so that you can remember it for both of them together. So basically here we are doing two things, two topic at the same time. We are doing the topic of electric dipole moment. We are also doing the topic of magnetic dipole moment. Shall we move ahead? Yes or no? Have we noted this down, everyone? Let me know once you are done with it. Once you are done, please let me know, bacha.
Done, sir.
Boys, are we done? Shall we move ahead, beta? Okay, I think we are done. Not able to hear you. So now comes the value of electric field. Electric field at the actual point for electric dipole is given by this formula, 1 by 4 pi epsilon naught, which is k into 2p divided by r cube. Here it is given by this formula, which is mu naught by 4 pi. In place of 1 by 4 pi epsilon naught, you get mu naught by 4 pi. You can just note this formula because these both the questions are exactly similar. The only difference is here this 1 by 4 pi epsilon naught is your k constant. Here mu naught by 4 pi is your k, which is constant. Do we understand this? So you just have to remember What is the value of K in both cases? In the case of electric dipole, it is 1 by 4 pi epsilon naught. In case of magnetic dipole, it is mu naught by 4 pi. Rest everything is exactly same. We understand this, yes or no? Just note
Yes,
this
sir.
down. Electric field at axial point, electric field at equatorial point, magnetic field at axial point, magnetic field at equatorial point. Exactly everything is same. In place of P, we have M. In case of electric field, we have magnetic field. In place of K, which is 1 by 4 pi epsilon naught, there we have mu naught by 4 pi. I'll give you 2 minutes to note it down. Anyone having any doubt, please ask. Formulas are exactly same. Don't worry. When we do magnetic field, I will come back to these formulae once again and I will show you this table once again. Right now, just note them down, everything together. Okay?
Done, sir.
Boys, have you done? Okay. Now, the next heading is dipole in a electric or magnetic field. Since we are dealing with both the dipoles together, so we will deal with both the dipoles together. So you can write dipole in electric or magnetic field. Dipole in uniform electric field is written by E vector. Magnetic field is written by B vector. Now, remember, whenever a dipole, whether it is electric dipole in electric field or bar magnet in a magnetic field, whenever they are placed in a uniform electric or magnetic field, 2 points that you have to remember. 2 points you will have to remember. Point number one, net force is always zero. Net force is always zero. Point number two, torque vectorly is given by P cross E. It is the cross product of P with E or the cross product of M with B. P means electric dipole moment, E means electric field, M means magnetic dipole moment, and B means magnetic field. If I just have to write the magnitude of torque, that will be equal to P sine theta into E, or it can become M into B into sine theta. If you're wondering what is theta beta, don't wonder, because theta is nothing but theta is nothing but the angle between theta is nothing but the angle between theta is nothing but the angle between dipole moment and the magnetic field, a dipole moment and the electric field, or the dipole moment and the magnetic field. Remember, torque is 0 if theta is 0 or 180 degrees. So, if your electric field E and your dipole moment P are parallel or they are anti-parallel, for example, magnetic field is like this and your magnetic dipole moment is like this, in that case, torque is 0. Do we understand what I'm writing here? Yes or no?
Yes, sir.
Torque is maximum if theta is 90 degrees, and maximum torque is P into E, or it is M into B. And that will happen when your electric field and electric dipole moment are perpendicular to each other. I'll give you 2 minutes to note this down. Once you are done, beta, please let me know.
Done, sir.
Boys,
Sir.
done, sir?
Yes, sir.
Okay. Now, the same thing I am going to show you with a diagram. With this diagram, so you can draw this diagram, both of them together in one frame. It will help you in understanding why is the force 0 and why is the torque not 0. So this is the diagram. On the left hand side, you can see the electric dipole placed in an electric field. On the right hand side, you can see a magnetic dipole placed in the magnetic field. You can see On the electric dipole, there is one force QE acting in this direction, but there is an opposite force QE in this direction. These two forces cancel each other out, and therefore the net force is zero. But these two forces make a couple, and therefore the torque is not zero. But when the dipole is straight, horizontal like this, the force as well as the torque is zero. Same thing happens here. One force is in this direction, one force is in this direction. Net force is zero, but the torque is not zero. Do we understand this? Please note this down. Are you able to understand beta what we are writing? Yes or no? Let me know once you are done.
Done, sir.
Boys? Okay. Then we should move ahead and write the next heading, energy of a dipole in a electric or magnetic field. So next heading is energy. Energy of a dipole. Any dipole when it is placed in any electric field, electric dipole in electric field or magnetic dipole, bar magnet in a magnetic field, it has energy. This energy is given by U, and the formula is there it was cross product in torque, in energy it is dot product. P dot E for electric field or M dot B for magnetic field. M dot B. You can write this as P into E into cos theta Energy at any angle theta will be P into E into cos theta, or you can write it as M into B into, why I'm writing sin theta, M into B into cos theta. Energy. Energy. Energy is minimum when theta, sorry, it should be negative. I forgot the side, the negative sign. Energy is minimum when theta is 0 and the minimum energy is minus P into E. That condition is known as the condition of stable equilibrium. Stable equilibrium is the condition which has minimum energy. We will see this condition, don't worry. Minimum energy is the condition of stable equilibrium. Then energy is maximum when theta is 180 degrees. The value is plus P into E. This is the condition which is known as condition of unstable equilibrium. And in unstable equilibrium, we have maximum energy. Energy at 90 degree is 0. Energy at 90 degree is 0. But 90 degree is not known as stable or unstable equilibrium. 90 degree is 90 degree. 0 degree is known as stable equilibrium, and 180 degrees is known as unstable equilibrium. You can draw this diagram if you want to for both these dipoles. Theta is the angle between the dipole moment and the magnetic field. Do you see it? Yes or no?
Yes, sir.
Okay, you want to draw this diagram? I'll give you 2 minutes to draw this diagram. We are dealing with electric dipoles and magnetic dipoles together. We'll come back to this again once more when we do magnetic field. Noted it down, bacha?
Yes, sir.
Okay. Then you can draw this diagram as well for stable, unstable, equilibrium. This is the diagram that you can see. When theta is 0, the equilibrium is known as stable equilibrium. What is stable equilibrium? If you try to disturb it from this position, it will come back to its position. So when theta is 0, torque is 0, work done is 0, energy is minimum, that energy is known as, you just don't write this work done wala thing. You will not be understanding what is this work done. You just don't write this work done. We will do this work done together. So at stable equilibrium, theta is 0, potential energy is minimum, torque is 0. At theta is equal to 90 degrees. This is theta is equal to 90 degrees. Torque is maximum, energy is 0. At theta is equal to 180 degrees, unstable equilibrium, torque is 0 and energy is maximum. Do you understand these three cases? Yes or no? Okay, just note down these three cases, beta.
Done, sir.
Boys, are we done? Are we done, beta?
Yes, sir.
Okay. Now, write the next heading. Work done in rotating a dipole. Work done in rotating a dipole. How much work is done in rotating a dipole? You might never get a question on this, but just remember this. Work done in rotating a dipole from angle theta 1 to theta 2 by electrostatic force will be equal to energy at theta 1 minus energy at theta 2. Now energy at theta 1 is minus PE cos theta 1 minus of minus PE cos theta 2. So you can write this as PE cos theta 2 minus PE cos theta 1. In case of magnetic moment, it will be m into b into cos of theta 2 minus cos of theta 1. Do we understand this? Yes or no? One more important point you must remember. If a dipole is placed in a uniform electric field, it will stay in a direction of stable equilibrium, that is, it will stay parallel to electric field because it wants to stay in a stable condition. It will always stay parallel to the electric field. Do we understand this? Yes or no?
Yes, sir.
These are the certain things that you must remember about electric dipole and electric dipole moment. Okay, now we'll try to do some problems on this. For example, this one. Has anyone noted down the formulae?
Yes, sir.
Yes, sir.
Okay, this is the first question. The torque which is acting on a dipole moment P in an electric field E is given by which formula? Yes, beta. Anyone with an answer? Anyone with an answer? Torque on a dipole in an electric field, what is the formula? No one knows it? Okay, the formula is P cross E. We have just seen it, beta. You should remember it. Okay. Okay, this is the next question. Electric potential at an equatorial point. We're talking about potential on an equatorial point. Electric potential at an equatorial point due to a small dipole. Dipole is always taken as small. At an equatorial point, what is the potential? We had discussed this in the previous class. Does anyone remember it? Does anyone remember it? Potential at equatorial point, perpendicular bisector. Does anyone remember it?
Option C.
Option C is not correct. At the equatorial point beta, potential is zero. Cancel out each other. You must remember things better. There is no point of we doing it in the class. You must remember it. Equatorial point. We done this in the class. You don't seem to recollect it. See, this is the equatorial point. Potential is zero. Equatorial means perpendicular bisector. Potential is zero. We have seen it in the previous class. I don't think you are paying enough attention in the class. Anyways, chalo, let us move on to the next question. These are the type of question that you expect in an examination hall. Next question. A point Q lies on the perpendicular bisector of a dipole of dipole moment P. If the distance of point Q from the dipole is R, what is the electric field at the dipole proportional to? Electric field at point Q proportional to? We have also discussed this question. What is the answer for this one? Abhiram says option D. Give me a correct answer with confidence, not thinking. Thinking will not help. We have just now noted it down in the table also. Equatorial point, electric field. You must be confident. You have written it so many times. My son, he is in standard 2. He writes a thing 5 times. He remembers it. You are in standard 12. You should also develop the same habit that if you write things, you should be able to remember them. So the answer is D here. It's proportional to P, directly proportional to P, and indirectly proportional to R cube. You must remember it. There is no excuse for not remembering it. Okay. Chalo, we move on to the next one. I hope more people will be able to give me the answer for this one. Let's shoot. What is the answer for this one? An electric dipole in a uniform electric field experiences what? It is placed at an angle theta with the field. What does it experience? Yes, bacha. What will it experience? We know the formula for both. A dipole is placed at an angle theta with an electric field or magnetic field. What does it experience? No one knows it? Okay. Abhiram comes up with an answer. He is the only one who knows anything. It experiences torque, but no force. Net force is zero. Torque is P into E into sine theta. I don't know what everyone has written. I hope you have written it correctly, beta. I hope so. Chalo. These are the type of questions that are going to come, and you may see a same question in the examination hall. I hope you are paying enough attention to the questions that we are doing. This is the next one. Next one. An electric dipole has magnitude of its charge as Q and its dipole moment is P. It is placed in a uniform electric field E. Its dipole moment is along the direction of the field, like this, same in direction both. What is the force on it and the potential energy? What is the correct option, my dear friends? Force on a dipole and its potential energy. Yes, bacha. Abhiram is the only one who is giving answers. Force is 0, potential energy is minimum, angle is 0. So the answer is C. Well done, Abhiram. Well done. Hello, next one. I'm still hoping that I'll get more answers. Questions are similar, same. Not much changes in from one question to the other question. These are the type of question that you're going to find in the examination hall, bacha. Comes the next one. An electric dipole of dipole moment P vector is in a uniform electric field E has minimum potential energy when the angle between P and E is what? Minimum potential energy. When does it occur? When does it occur, my dear friends? When do you have minimum potential energy? No answers, anyone. The potential energy is minimum. Stable equilibrium. The angle between P and E is 0. That is the point. That is the time when the potential energy is minimum, my dear friends. I hope you will remember it. Next question. An electric dipole moment P is placed in a uniform electric field E. Then the angle between P and E for torque to be maximum. I want the maximum torque. What should be the angle between P and E?
Option C, 180 degrees.
Option C, 180 degrees. No, the answer is 90 degrees. Torque is P into E into sine theta. It is maximum when angle is 90 degrees, beta. Maximum when the angle is 90 degrees. You also written it. If you remember, we written it. We've written it so many times. How can you get? It seems that you are not writing it correctly, beta. If you are writing it, you are not remembering it. Both are dangerous signs. If you are not writing it, dangerous sign. If you are not remembering it, more dangerous. Please remember it. You'll find a similar question in your examination hall, beta. You'll find a similar question in an examination hall. Please remember it. Next one, the last one. And I hope I can get an answer for this one. I will be very pleased if I can get an answer. And this is the one. The electric field at a point on the equatorial line. We're talking about the equatorial line of a dipole and the direction of dipole moment. What is the angle between electric field and dipole axis at any point on the equatorial line? What is the angle? I've given it as an important point in your notes. What is the angle between electric field and dipole axis when the point is on the axial point? and when it is on the equatorial point. Anyone remembers it? Anyone remembers it? When the point is on the actual point, the electric field and dipole moment are in the same direction. But when the point is on the perpendicular bisector, they are in opposite direction. Please remember it. Well done, Abhiram. So this is how we end this particular topic of electric dipole. Everything that you need to know is in your notes. Please find time out of your busy schedule to go through those notes and do the questions that we have done in the class. They are more than enough. They are only going to ask you what is the angle at which energy is minimum, torque is zero, torque is maximum, will there be force or torque, what will be the energy. These are the simple type of questions that are going to come, and I hope that you can do better in the exam, but you could not do so better in the class. I hope you would be able to recollect, and you have time for today. Today you can go back home and do this small topic of dipole moment at your home. I would be very pleased. So please do that, and I'll see you in the next class. In the next class, we will be doing with the properties of conductors and moving on to the next chapter, which is capacitors. Take care, and God bless all of you. Bye bye. Bye, beta.